ladies and gentlemen. My name's Stephen Chivers, Managing Director for Blue Clarity Design Services. We are technical specialists in the utility, that's telecoms, water and electric, and architectural sectors, where we plan, survey and design infrastructure and commercial and residential developments. So it's our ability to exploit technology, innovate and provide a safe and cost-effective design is certainly key. And that also goes through to construction and over the life cycle of the project. Therefore, I'm going to provide a brief overview of building information modelling, underground and up. To recap, certainly by the end of the day, I think you'll all be BIM specialists if you've been here in every presentation. So I'm going to come at this as a slightly different angle. I'm going to come from this as a practitioner, someone who applies this in practice, and I've got some good examples. So to recap, for those that may have missed the significant development in the construction industry, BIM, Building Information Modelling, is a process of creating and managing all present information in a digital format, every aspect of built technology. Therefore, before, during and after construction, it's a case of model before we build. Model before we build, and that's an important aspect. Because in practice, we're all aware that inaccurate, incomplete, and ambiguous information leads to mistakes. And these mistakes cost money. Therefore, the BIM strategy to target 20 to 25% reduction needs to be driven by off-site modelling, information at the right time, accurate information to enable us as designers, as architects, to make better decisions through that design process, through the construction process, but also through operation. The emphasis is always on being effective and efficient. Effective and efficient. One of the historical problems and resultant delays and additional costs is often utilities, a necessary evil, unfortunately, with a lot of new developments. Legacy as-laid records are often poor, location with traditional methods is difficult, and this can often lead to unexpected clashes, diversions, or even misconnections and additional cost, let alone miscompletions and handovers of commercial and residential buildings. So this is an area we've been focusing on, and we've seen already a reduction in issues and costs. So just as we have BIM, which optimises the building process, important for us, we need a methodology. That methodology is the execution plan, which optimises the BIM process for shared planning and knowledge. It's how the team use BIM in practice, the level of detail, the separate models, the coordination of the design team, the owner, the contractor, the meetings, the agenda, the project goals for collaboration, how we set that information up for modelling, the design of that model, the interaction and the existing infrastructure and liaison with mechanical and electrical and plumbing, etc., other services. And of course we mustn't forget how our model references technical specifications and also our duties, our regulations and legislations that we must comply with. In the UK, England, Wales, Scotland and Northern Ireland, we have the Construction Design and Management Regulations 2015. They set out the principle for designers to make sure that they are coordinating the pre-construction elements of that part of the contract. The principles of prevention to eliminate, reduce and control risk and provide information on remaining risk is certainly key. And we also have to collate information to hand over to the health and safety file. So it's vitally important for us in that particular process to look for where are we going to get these efficiencies. If we are using BIM, where can we use BIM to comply with regulations and legislation? The new Roads and Streetworks Act is another good example where we have to coordinate with other utilities, with councils. We undertake liaison. Where can we use our BIM models at an early underground stage to help us and get the efficiencies and effectiveness out of that particular project? Our architects are aware certainly of council's development and planning policies, and certainly that we, in order to do the town planning and approval stage, our surveyors plot out site dimensions, levels, inputs, features, service pits, and also street furniture linked to utilities. These are derived from as-laid plans where impact analysis, from diversions, risk assessments, and points of connections are often identified. Traditionally, as you see on the right-hand side, these are flat 2D drawings. With building information modelling, our architects now require a 3D model where they can design sewers, stormwater, and building connections to make sure that there are no particular clashes downstream or during construction. Therefore, it's our ability as utility designers, we're now modelling in 3D. As you can see from the example, that's typically the above ground, which is in common use. But not many people now model underground. So how do we get the below ground data? In order to trace and locate services horizontally and vertically, we are using ground penetrating radar. So this identifies service features where radar penetrates the ground and it identifies features in the subsoil. Sometimes it's difficult with traditional methods to actually trace these with electromagnetic methods, where you need a conductive utility to actually identify not only just the horizontal, but also the vertical depth, which is often a problematic issue. But with ground penetrating radar, this will identify plastic, gas mains, water mains. With the increased use of fibre optics in telecommunications, we can also look at the line and level of these. So it's important now that we're getting to a greater level of detail, certainly in concrete structures and other obstructions, which may, at a point of construction, be a major issue and have additional costs. So how has this helped us on the BIM process? As you can see, we're going into a far greater level below the ground. So this is a ground penetrating radar that we undertook. We've used a topographical survey to make sure that we pinpoint accurately all the data, and we've modelled that in 3D CAD. Here's a good example. So we have an HV connection identified by the electricity company in the highway, 1.2 metres from the curb, with a twin duct crossing right up on the right-hand side. Also, we have a sewer connection, 1.9 metres from the near side curb, requiring traffic lights and out-of-hours working. By undertaking a thorough ground penetrating radar survey and a model, what we've established, in fact, the proposed HV connection was under a buried BT chamber, far deeper than expected and the location unsuitable. The model provided us an ability to provide a new location, revised ducts and depths. This saved a considerable amount of time. It could have been a delay to temporary building supplies to the site. There was cranes on site with the cost of fuel of £1,000 a week. And plus there was the on-site commissioning that was all dependent on electricity being provided, let alone the claims and disruptions that could have been from road users. The second example was the sewer manhole, offset some 2.1 metres down. As you see from the drawing in the middle, if you looked at a typical survey from setting out flat 2D, we would have just joined up the manholes, but in fact the manholes and the sewer was set to one side. The impact of that was, in fact, it was only 0.9 metres from the curb, therefore we could minimise the traffic disruption, cost, time and materials. So by modelling, not only we identified potential on-site issues and unplanned revisions in costs, but more importantly, we modelled cost-effective solutions before construction. A real good practical example. So although we've a detailed model, we still publish 2D plans for setting out and commissioning. We can't get away from that, that's still an important aspect. But these proposals have been modelled really to flush out any clashes of designs, thereby reducing cost and risk. The execution plan is followed, where milestones have been agreed for model sign-off and approval. And also that we collate the complete detailed BIM model and hand that over to the client for payment. So just in summary, we've identified some early risks by modelling designs below the ground. These have avoided on-site delays and cost overruns. We've found our architects have more accurate information to enable them to make better decisions. Combining BIM with construction design and management regulations, we ensure compliance and we have a far more effective and efficient design process. As you can see, in April 2016, a survey of 1,000 UK construction professionals revealed that BIM had increased from 13% in 2010 to 54% in 2015. So BIM's here to stay. And from our experience, from the underground up, it has already started to be more efficient and effective way of producing designs, and also we're starting to see some reduced costs, which is the real philosophy of BIM. Thank you.